Concept of enthalpy. There are several important terms in thermochemistry. Heat means the energy transferred between two bodies of different temperatures. System. In a chemical reaction, reactants and products are considered as system. Surrounding include vessel and the air or other material in thermal contact with the reaction system, means air or material that in contact with reactants and products. Heat flow. Before I'm going to explain on heat flow, you need to understand the definition of enthalpy. Enthalpy is the heat content of the reacting system. Heat flows from the cup of tea to the room and it loses heat. Its temperature drops and it will reach thermal equilibrium with the room when they are at the same temperature. This cup of tea will keep losing heat until the temperature of the cup of tea and the temperature of the surrounding are the same. The ice slowly will absorb heat from the room and will melt as it reaches thermal equilibrium. Two or more bodies are said to be in thermal equilibrium if they are at the same temperature and there is no net flow of energy between them. Means this ice slowly will keep absorbing heat into the ice slowly until the temperature of the surrounding is the same of the temperature of the ice slowly. Means there is no net flow from the surrounding to the ice slowly or the ice slowly to the surrounding. That's what it means by no net flow of energy between them when the temperature of surrounding and the ice slowly are the same. There are three types of system: open system, closed system, and isolated system. Open system is a system that can exchange mass and energy with its surroundings, while closed system is a system that allows the exchange of energy only, not mass and energy only with its surrounding. Isolated system is a system that does not allow the exchange either mass or energy with its surroundings. Example, water in a flask. When there is no lid of this flask, water vapor can enter and transfer out of the flask, and the heat can also be transferred into the flask and out of the flask. So there is exchange in mass and energy in an open flask. So this is open system. For this one, when you close the flask, this is closed system. There is a lid, closed system. Only energy can be transferred in and out of the flask. And this one is isolated system. Isolated system, the flask is isolated, so no mass, no energy can be transferred in and out of the flask. There are two types of chemical reactions: endothermic reaction and exothermic reaction. Heat is absorbed from the surrounding to the system. That's for endothermic reaction. Heat is absorbed from surrounding to the system. When heat is absorbed into the system, there will be increase in the enthalpy of a system because you absorb the heat, energy is absorbed, so increase in enthalpy, increase in the heat of the system. It means the enthalpy of reactant is less than enthalpy of product because at the end, the result, at the end, the energy of the product or enthalpy of the product is more than the enthalpy of the reactant. The value of delta H equal to positive, or it must be more than 0. That's what it means by positive value. In exothermic reaction, heat is released from the system to the surrounding. Means the heat initially is less than heat after. So the enthalpy of reactant is more than enthalpy of product. The delta H is equal to negative value or less than 0. Endothermic example: when liquid water vaporizes to become this water vapor or gas water, the heat flows into the liquid water from the surrounding. The reactant, 1 mole of liquid water, here 1 mole liquid water, absorb heat during the process. So liquid water originally had less enthalpy because it absorbed the heat. So initially less heat. When it absorbed heat, there will be more heat in the system. Liquid water originally had less enthalpy than the product, the 1 mole of water vapor. So when heat is absorbed, so delta H equals to positive. You're adding heat into the system. So delta H equals to positive 44 kilojoule per mole. This is the energy profile diagram for endothermic reaction. The reactant, liquid water, to becomes the product, water vapor or water in gaseous form. So initially, liquid water has energy less than product because this liquid water will absorb heat. When it will absorb heat means it will absorb energy, means heat or energy initially is less than energy after. That's why here you can see the energy value of reactant is less than the energy value of the product. So your energy profile diagram for reactant here must be less than the product. So this is the curve for energy profile diagram of the endothermic reaction. This is the activation energy, the energy required from the reactant to become activated complex. And delta H is from the reactant to become the product. And since the energy is absorbed, so delta H equals to positive. Endothermic energy is absorbed. Exothermic example: when methane gas burns in oxygen gas, the heat will be released. So initially, there is a particular value of heat, and that value of heat will be released or flows out from the system into the surrounding. Means initially you have more heat, after that you have less heat because heat is released. So when heat is released, delta H is equal to negative. Heat is released. The reactant, 1 mole methane and 2 mole oxygen, release heat during reaction. They originally had more enthalpy than the product. 1 mole carbon dioxide and 2 mole water. So here methane and oxygen has more heat than the product. When the heat in the reactant release, heat in the product will be less. This is the energy profile diagram for exothermic reaction. For exothermic reaction, initially you have more heat, and then you will release heat, product will be having less heat. So that's why the energy of reactant initially is more than the energy of the product. So this is a curve of exothermic reaction. Activation energy, again, energy required for the reactant to become the activated complex. So this is the activation energy. And delta H is energy required for reactant to become the product. This is the delta H negative because energy is released. Enthalpy change, symbol delta H, is the difference between enthalpies of the products and enthalpies of the reactant. So delta H is equal to enthalpy products minus enthalpy reactant. So as you can see here, for endothermic, the enthalpy of reactant is less than enthalpy of the product, because endothermic reactant will absorb heat. So initially less heat, after that product more heat. So more at the product, less at the reactant. Delta H equals to the product minus reactant. So you have product greater than the reactant, enthalpy product greater than the reactant. So a value of delta H is equal to positive, because here enthalpy product is more than the enthalpy reactant. So that's why here is positive for endo. For exo, the enthalpy of the product is less than the enthalpy of the reactant, because heat is released to the surrounding. So in the system, the enthalpy will become less at the product, because heat is released to the surrounding. So in the product, less enthalpy. We know that delta H is enthalpy product minus enthalpy reactant. So when this value is less than the value of the reactant, enthalpy reactant, that's why you will get negative value, because delta H is equal to enthalpy products minus enthalpy reactants. Enthalpy reaction can be positive or negative, depend on the process, whether it is endothermic or exothermic. Why endothermic has positive value? I've explained before, because the product enthalpy is more than the reactant enthalpy. The exothermic has delta H negative, because the product enthalpy is less than the reactant enthalpy. That's why exothermic delta H is negative. Standard enthalpy, the value is delta H naught to the power naught here. Enthalpy change measured at standard condition. The standard enthalpy is the same like enthalpy, same like before, but it is measured at standard condition. The enthalpy is measured at 25 degrees Celsius or 298 Kelvin and at 1 atmospheric pressure. The standard states are 1 atmospheric pressure gas, and then the concentration must be 1 molar, and the substance must be in its element or its compound, most stable form of substance at 1 atmospheric pressure, and the temperature must be 25 degrees Celsius. That are the standard state. When you want to measure the standard enthalpy, the enthalpy must be measured in these standard states. Thermochemical equation. The chemical equations that shows the enthalpy changes. So here, this is endothermic reaction, because it is positive. The delta H is positive, means the product enthalpy is more than the reactant enthalpy. So that's why delta H is equal to positive. And then for this one, hydrogen gas react with oxygen gas to produce water liquid. The delta H is equal to negative 286 kJ per mole. This negative sign shows that this is exothermic reaction. Exothermic reaction, negative sign means the product enthalpy is less than the reactant's enthalpy. That's why this is negative sign, exothermic reaction. If you reverse this, if you make the water as the reactant to becomes oxygen and hydrogen gas as a product, this sign will be positive. If you reverse the chemical equation, the sign of the enthalpy will be changed. It will be the opposite. A forward reaction has opposite sign of the reverse reaction. Stoichiometry of thermochemical equation. So this is the chemical equation, and you have the delta H equals to negative 890.4 kilojoule per mole. Here, negative sign, from here you can interpret that the negative sign, this is the exothermic reaction, means heat is released. Initially, the reactant has a particular amount of heat and heat is released to the surrounding, making the product has less enthalpy than the reactant. So when product enthalpy is less than the reactant enthalpy, delta H means enthalpy product minus enthalpy reactant. So that's why this is negative. So this is exothermic reaction, heat is released. So the sign, from here you can identify the sign. It is very important to identify the sign to identify whether it is endo or exo. So if it is negative, it is exothermic reaction, heat is released. And here, stoichiometrical relationship. If you look at here, kilojoule per mole means here the delta H for 1 mole. 1 mole CH4, here 1 mole CH4 reacts with 2 mole oxygen to produce 1 mole CO2 plus 2 mole H2O. So this stoichiometry for each mole here represents whatever you have in the value of kilojoule per mole. So you can relate this stoichiometry with the value. If you have to half this, half CH4 reacts with 1 mole of oxygen to produce half carbon dioxide and 1 mole of water. This delta H must be half value of 890.4. It will be half. So that are two important aspects of delta H that you need to look at: the sign and the magnitude of stoichiometrical relationship. If positive or negative, if I explained before, if it is positive, it is endothermic, and if it is negative, it is exothermic. Magnitude, so here if you have 2 mole H2, 1 mole oxygen, 2 mole water, the delta H is negative 572. And if you half this all stoichiometry of the reaction, half all the reaction stoichiometry, the hydrogen will become 1 mole, this oxygen will become half, this water will become 1. You need to half the delta H as well. Some important types of enthalpy changes. There are 6 types of enthalpy changes in your syllabus: enthalpy of formation, enthalpy of combustion, enthalpy of atomization, enthalpy of neutralization, and enthalpy of hydration. One more is enthalpy of solution or dissolution. 6 types of enthalpy changes. We'll go through one by one. Standard enthalpy of formation, delta H naught F. Here it shows the naught, shows the standard. The formation is in standard condition. The standard enthalpy formation is the heat change when 1 mole compound is formed. That is standard enthalpy of formation. 1 mole of compound is formed. Cannot be 2 mole, cannot be 3 mole. It must be 1 mole of compound is formed from its element in their most stable states at standard condition, means it at 1 atmospheric pressure, and the temperature must be 298 Kelvin or 25 degrees Celsius. For example, here 1 mole of water is formed from its element in their most stable state, means this hydrogen, the most stable state of the hydrogen is gas. So this 1 mole of water is formed from hydrogen gas and oxygen gas. Here oxygen, its element in the most stable state. This oxygen, the most stable state is gas, so oxygen gas. So here 1 mole of water is formed from 1 mole of hydrogen gas and half mole of oxygen gas. The stoichiometry of the reactant does not matter because we want to look at 1 mole of compound form, means the product form. Here must be 1 mole. Cannot be half, cannot be 2, it cannot be other than 1. It has to be 1 mole of the product. Because the definition enthalpy of formation is 1 mole of compound is formed. So given the delta H HF for water equals to negative 241.8 kilojoule per mole. If you look at the enthalpy of formation of water, carbon dioxide, carbon monoxide, all of them are exothermic reaction. Negative value means exothermic reaction. Standard enthalpy of formation of any element in its most stable state form is 0 because the elements are formed from their respective atoms or element. In order for the oxygen gas to form, their stable state is already oxygen gas. This is how it exists. So the standard enthalpy formation of oxygen gas equal to 0, and for chlorine, in order to form chlorine is equal to 0 because this is how chlorine already exists. So that's why it's equal to 0, because you don't need other one chlorine atom to react with another one chlorine atom to form Cl2. This is how chlorine exists, Cl2. So this standard enthalpy formation of chlorine is equal to 0. For hydrogen, this is how it existed. So this is 0. And for carbon in the form of graphite is equal to 0. Usually, if the question doesn't give you the value of standard enthalpy formation of their own element, it's a most stable state, you have to know that it is 0 because it existed as it is. If the delta H not F is the standard enthalpy formation is less than 0 or negative value, it shows that the compound is more stable than its component elements. Here we know that carbon exists as graphite, so the standard enthalpy formation is equal to 0, but we also has diamond. Diamond is made from carbon, but the standard enthalpy formation of diamond is positive 1.9, means here it's more than 0, so it's less stable. If it's less than 0, means it's more stable. So the CO2 gas, the value is negative, so this is more stable than its component element. Here negative, more stable than its component element, and CS2 positive, less stable than component elements. Enthalpy of combustion, delta HC. Heat released when 1 mole of substance completely combusted in oxygen gas. So when we look at enthalpy of combustion, that 1 mole of substance must react with oxygen gas. 1 mole of carbon react in oxygen gas. The delta H combustion equals to negative 393.5 kilojoule per mole. So the delta H combustion must be negative. Heat is released when the combustion process happens. This is exothermic reaction. For enthalpy combustion, exothermic reaction. Next, enthalpy of atomization. Heat absorbed. Keyword heat absorbed. We know that this is endothermic. Enthalpy of atomization, the heat absorbed when 1 mole gaseous atom is formed from its element. So the product of equation enthalpy of formation must be in gaseous atom. Because definition of enthalpy of atomization is heat absorbed when 1 mole of gaseous atom is formed. Example, sodium solid, product sodium gas. So this is 1 mole of gaseous atom is formed. The product must be in gas for enthalpy of atomization because the definition 1 mole of gaseous atom is formed. And delta H must be positive because it is endothermic, heat absorbed. Endothermic. That's for enthalpy of atomization. Enthalpy of neutralization must be exothermic because the definition is heat released. Heat released when 1 mole of water is formed. So enthalpy of neutralization, in the equation, you must have 1 mole of water. Not 2 mole, not 3 mole, not half. It must 1 mole of water is formed when acid reacts with base. So in your enthalpy of neutralization, the reactant must be one of them acid and another one base. So that is enthalpy of neutralization, exothermic because heat release. So negative value, negative value. Reactant must be acid and base and the product must have 1 mole of water. Then that is enthalpy of neutralization. Enthalpy of hydration, exothermic reaction because the definition is heat released when 1 mole of gaseous ion is hydrated. So the reactant must be 1 mole of gaseous ion. It must be ion and it must be 1 mole and that ion must be in gaseous state because the definition is 1 mole of gaseous ion is hydrated in aqueous solution. So the product must be aqueous. The product must be in aqueous form. Delta H value must be negative because the definition of enthalpy hydration is heat released. So exothermic, negative value. Next, enthalpy of solution. Heat change when 1 mole of substance dissolved in solvent water to form an infinite dilute solution. So you have 1 mole of substance. So here, for example, we have 1 mole of KCl in solid form and that product must be in ion and aqueous. It must be in ion and it must be in aqueous form because to form infinite dilute solution. So dilute solution, aqueous, aqueous, and it must be in ionic form. So enthalpy solution, delta H positive. Exercise 1. Write a balanced equation and draw an appropriate enthalpy diagram for each of the following. A. The combustion of 1 mole of methane. So you burn 1 mole of methane in oxygen gas, releases 809 kilojoule heat. You must write balanced equation. So releases heat means the combustion exothermic reaction. Releases, heat is released, so it is exothermic reaction. So you have to write the balance equation and you have to draw the energy profile diagram. So here 1 mole methane reacts with oxygen and then you have to balance the chemical equation and then the delta H equals to negative because heat release for combustion, exothermic, negative 809 kilojoule per mole. Delta H must be per mole because that's for 1 mole of methane. And the energy profile diagram, since this is exothermic reaction, heat release means after that the product will have less enthalpy. So reactant will have more enthalpy. So here energy of reactant must be more than energy of the product. So, and you have to draw the activation energy arrow. Also show the delta H value. Delta H from reactant to becomes product. Activation energy from the reactant to becomes the activated complex. That's the energy profile diagram for exothermic reaction for the combustion of methane. B, the formation of one more NO2. So here enthalpy of formation of NO2 from its element at 25 degrees Celsius and 1 atmospheric pressure absorbs 34 kilojoule heat. Absorbs 34 kilojoule heat means this is endothermic reaction. It absorbs heat. Endothermic reaction means the delta H must be positive. So you have to write down the chemical equation of formation of NO2. Means the nitrogens react with oxygen to form NO2. This is a chemical equation. So formation means one mole is formed. So this NO2 must be one mole. And then other than that, you have to balance the chemical equation. Delta H must be positive because the energy absorbed means that is endothermic reaction. So your endothermic reaction profile diagram, since the heat is absorbed, means you will have more heat at the product, the energy of the reactant will be less than the energy of the product. So that's why here it is higher than the reactant. The activation energy required for the reactant to become the activated complex. So this is the activation energy level, and delta H from reactant to become product. So here from reactant to become product, delta H positive.